Thank you, Mr. Prasad. That was a very, very interesting presentation. Come on, give him another hand, everyone. Louder. We'll be next moving to our next presentation done by Dr. Shivanand Wagle from the Manipal Group. Dr. Wagle is actually a PhD in chemistry from NITK Surathkal and is currently the AGM R&D at Manipal Press working on long-term projects. Doctor?
In my presentation, I'm going to cover the introduction, how printing is used in printed electronics, inkjet printing, use of inkjet printing in printed electronics, what are the advantages, challenges we face, and future of inkjet printing for the printed electronics. And as a printer, our expectation of inkjet printing for printed electronics. The word printed electronics or plastic electronics or again organic electronics was coined around 2000. So basically it is uniting the world of graphic printing and electronics. When we say graphics, the first name we could see the Gutenberg, who introduced the printing, and Kelby, who introduced the first printed integrated circuit. Today, for Manipal Technologies, printing is a passion, whereas we feel printed electronics is a future. So the right side display is a completely printed display using conventional printing technologies. With a electrical connection or power connection, the display is going to glow. What is this printed electronics? Basically, printed electronics is printing the functionality rather than the colors. We print conductivity, we print semiconductivity, we print dielectric or non-conductivity functions, where graphics reveal the aesthetic look of the particular product, where printed electronics give the interactivity. Interactivity in the form of color, interactivity in the form of sound, maybe interactivity in the form of power generation, or interactive in the form of smartness, in the form of memory, and many more. So what are the motivation for this particular printed electronics? Basically, large area or roll-to-roll processing. We use large conventional printing methods to print electronics in a roll-to-roll form. That is the advantage of printed electronics. And ease of material handling, which is very difficult in the conventional electronics, where conventional electronics use a clean room facilities, where we are intended to use a normal printing facility for electronics application like material compatibility, substrate topography, or fragility are eliminated in printed electronics, where we use flexible materials in place of glass. Thin product form, again they may be rollable, bendable, ranging from 50 micron to 200 microns thickness. Price, we feel the price of printed electronics will be low because of the mass productivity, and definitely there are few questions with respect to memory part. They say the cost of the especially RFID is crashing drastically using conventional methods, where we feel still lot of work has to be done to match the price. Then we use well-established printing process for electronics printing. Another motivation for printed electronics would be one-step method, and it is an additive printing process, where for the conventional electronics we use 6 steps, maybe different sintering, patterning, exposing, and the biggest bottleneck in the conventional electronics is the clean room facilities, which attracts lot of investments for startups. Whereas we use the conventional printing machines in a semi-clean room facilities to print the functionalities in the form of printed electronics. There are numerous methods, printing methods to print electronic functions. Maybe inkjet printing, gravure, offset, flexo, screen. Although we say offset, there are few bottlenecks like the thickness of the layers, mainly due to the functionality of the conductivity and non-conductivity. Then other methods like nano imprinting, laser transfer printing, nano lithography, dry printing, hot embossing, laser processing, stamping or die cutting, mainly used for the RFID applications, and different coating methods like slot die coating, dip coating, or spray coating for 3D functionalities, roll-to-roll etching and photolithography, and other methods like lamination is another method for printed electronics. So although we use many methods for printing methods for printed electronics, customer doesn't care which and how printed electronics is being printed. Ultimately, for a customer, functionality is more important than the method of manufacturing or how you did that. In Manipal, initially we used inkjet printing mainly for printing conductivity applications. We formulated our own gold nanoparticle inks. We mixed gold nanoparticle with different solvents. Then this gold nanoparticle ink, in-house formulated inks were used for the conductivity applications. So there are many problems in the initial staging like jet blocking, pinholes in the printing layers, and the effect of solvents and co-solvents in the formulations. When we say printed electronics, it is a 50% of chemistry and 50% of technology. The initial inks are equally important for printing as well as the methods we use for the printing. Here are the two images where the effect of printed gold nanoparticles before and after drop modulations. That was the permutation combination we tried for the modulation of drop to get the uniform layers of conductivity. So once we are through with the conducting materials, we went for the non-conducting materials or dielectrics. We used PVPH, that is poly 4-vinyl phenol films, for different applications. Again, the ink was in-house formulated. The dielectric ink was formulated by in solvents called glycol. Then jetting and film performance was poor when only solvent was used. So we used a co-solvent along with the main solvent in different proportions, in the different ratios to overcome the bottleneck. Basically, a mixture of solvents and co-solvents were the good combination for a perfect end product. The application of printed electronics would be using these printed conducting and non-conducting materials, inkjet printed OTFTs. OTFTs is organic thin film transistors. These printed transistors are building blocks for major integrated circuits like RFID, memory, rectifiers, capacitors. So basically they have 7 layers of printing of gate electrodes, printing of source and drain electrodes, dielectrics, and semiconductors. When we print semiconductors, maybe a single layer of semiconductor may not sufficient because of the pinholes, which ultimately results in short of the circuit. So we printed multiple semiconducting layers, one over the another, using a 2 picoliter jetting. The high resolution channel length of OTFTs and were printed using drop on demand inkjet printers. The next product using inkjet printer was capacitors. Basically, capacitor is a organic metal, non-conducting and metal layers. MIM, metal insulating and metal layers. Again, the complete inkjet printed capacitors using silver nanoparticles. These are the printed resistors using inkjet printing. Basically, high resolution printing helps to develop resistors using high conducting ink, maybe using gold or silver. Basically, these are the data we generated using inkjet printing. Mainly jetting performance, printing quality, roughness of the each layer, thickness of the each layer. When we observe more roughness, we dropped that particular method and went for the new one. Then solvent effect, different solvent effects on viscosity basis. Maybe tetraline was found to be very good at 30% ratio. Current versus voltage was measured in each printed layers. That was the check for the printing efficiency using the printed inkjet printing. This is how we modulated the jetting of the inkjet droplets at a rate of 2 picoliters, and people are talking about a jetting of 0.5 to 1 picoliter in next 1 to 2 years in using inkjet printers. So what are the advantage of inkjet printing? Variable data patterns, then on-the-fly error corrections, non-contact printing, substrate with topography and fragile substrates. Today we are able to use very thin glass substrate in the flexible form for few of the applications. Then low operating cost, mainly because of the low ink consumption. Wide range of inks, maybe hot melting or hot melt wax, solder inks, biomaterials, low viscosity inks, solution based inks. These are the another advantage on inkjet printers. Still there are few challenges in printed electronics using with the focus on inkjet. That is mainly registration as a process challenge, chemical compatibility of the material with the inkjet head, physical compatibility, that is step coverage and work functions, curing, drying temperature, which is relevant for the base substrate. In most of the printed electronics products, we use PET, 100 micron PET, which can withstand a temperature of maximum 120 degree for 10 minutes. So most of the functional inkjet inks need higher temperature for curing and patterning. That is one process challenge we have. Online quality control to optimize process yield. Then controlled atmosphere sensitive materials. Most of the inkjet printable nanoparticles or conducting materials are very sensitive for moisture and heat. That is the challenge we are facing. And there are few material challenges like ink viscosity, printability, ink stability, material lifetime, again that is relevant to moisture, oxygen or ozone, cost of the inks, uniformity of printed layers, performance of the end product. For a customer, performance is more important than which method we have used. Process, solvent compatibility with the inkjet heads as well as the base substrate. Then wetting processes, properties of the ink. That determines the contact angle in between the jetted droplets and the substrate. So there are different application for inkjet for printed electronics. Basically, color filters, RFID antennas, printed photovoltaics. In printed photovoltaics, we can have some of the layers can be printed using inkjet, scratch resistance layers, sensors. Since IoT is coming in a big way, there are a lot of scope for sensors using printed electronic sensors since they are very flexible, very cost effective. LCD materials, OLED materials, electrophoretic media, electrowetting fluids, and electronics circuits. What is the future of inkjet printing in printed electronics? A precision printing shows great potential for printed electronics. So basically, a lot of people are using inkjet for the prototype generation rather than the mass manufacturing. Since there are many shortcomings in form of ink, area, printed area, and inject heads, people are using only to produce proof of concept products rather than the mass manufacturing. And drop on demand without physical mass is great advantage. Compatibility with organic and inorganic solvents is another advantage of inkjet inks, which could be having good functional materials into flexible materials. Then non-contact printing is another advantage, and people are talking a lot about 3D printed electronics. That is the next phase of additive manufacturing revolution, where we use functional materials in the form of instead of ABS or PLA, where they're using polymers to fabricate the 3D models. A 3D model with inbound circuitry within the sample. Although we say inkjet is a good method for printed electronics, there are few expectations from a printer. Basically, mechanism to manipulate the droplets, printing speed for high throughput delivery, printing of different size and form miniature circuit to large areas, capability to print different inks with control injettability of different functional materials, and integrate inkjet printing with other printing methods into roll-to-roll formats. Yeah, thank you for your attention.
Thank you so much, Doctor, for those very kind words as well as the presentation. And I must say, if printing companies and research carries on at this rate, very soon we're going to have printing companies and companies like Intel in the same sentence competing against each other, which is something that, we definitely should see down the line. We'll now start with getting the advisors on stage, and we'll have the question answer round after that. So among the advisors, I'll ask you to come up in alphabetical order. The first is Ms. Asha Sampath, the founder and head of growth and brand strategy at Brand Horizon. Please. Next, we'll have DJ Bangara, the founder and managing director at IDX India. Come on, everybody. Bigger round of applause. Next, Mr. Gautam Pai. Please. Mr. Himanshu Pandey. Mr. Narendra Parachuri. Mr. Prabhuda Dasgupta, Mr. Prasad Bhagwat, Mr. Sachindranath Udupa, and finally our sponsors for the evening, Scott and Sam. Would you please join us on stage? So we'll now move on to the question section. Does anybody have any questions? First, let me remind everyone, we've got a small section out there. If you can please come up and ask your questions. We'd love to have your handsome or pretty face on the camera. Questions?
What is it? No, it's okay. Prasad, the question is to you. Here, right? Okay. I know the light is in your eyes. So, in your presentation, you talked about India is actually still in the solvent printing stage and very little in the UV area. So, what is preventing us other than cost? I mean, why is industry bodies is not pressing the government if there is so much of an environmental issue? And what are the challenges? Why is the industry not moving towards UV?
It's a great question, actually. It's a question on everybody's face today. Why is that still? Can you hear me? Why is that India is still around 80 to 85% of the solvent market? Why is that UV is not able to penetrate? And we are one of the first guys in the market. Right from PV 200 onwards, we've been investing on the UV, knowing that it's going to be a great trend. The kind of pop what you get on a UV, you cannot get on solvent, because primarily the technology of solvent, the solvent bites the media and settles the pigment into it. Therefore, your graphics is going to be a flat. You don't get the right colors on top. Of course, a few technologies have come, the ink technologies that is actually has given a nice images through their hardware and software combinations. Of late, in fact, as I told you, that we have been investing on right from PV200 of Viewtech machines. Even now we have about 5 UV printers working in our platform, while the solvent is only about 3. So recently I came across one of my oldest client. Commercials, it has been mentioned as solvent print for signages. We didn't have a capacity to supply solvent print, so we have a huge capacity of UV. So what we have done is, we printed UV and given it to them. Of course, the PO doesn't change because of various, it's a pre-decided and thrown out PO. The commercials have noticed that, some of these prints go to the fabricators. They actually take it up, put it up, and then send the photographs to the brand guys. When their bills reach the commercial, they call the fabricators and then ask that, is this the print that what we asked has been given? They said no. Then they called me and said, why is that you have given UV print when I asked you solvent print? You have been blacklisted. See, the commercial guys actually have no knowledge about it. When he told me that, good, you blacklisted me, I'm very happy. I don't want to supply any more. The main question is that why is that India is not able to get into that? Even today, in spite of being about a decade plus that UV came into the market, the difference between solvent and UV is about 10 times output price. Therefore, that brands are not willing to get into that. So you need to reduce the production cost, supply cost, very close to solvent, then only you'll be able to do that. So that's, cost is the main factor here. Can you spend a place of 10 rupees, about $100? No commercial guy will accept that. So this is how they blacklist you all the time.
Thanks again. Maybe Scott, an adjacent question. So with our new line of machines coming in from Matan and all, does the cost of production will come down to much manageable limits?
Yes, especially with the Matan lineup, obviously the acquisition cost comes down, the printer cost, which is a factor in production. Also, I think one of the things that you have to look at when you look from a solvent to UV transition is really the total cost. It's all the elements of when you print with solvent, yes, it's very cheap ink price, very cheap per square foot in terms of ink. But oftentimes you have to lay the production out on the floor to dry. That's additional cost in real estate, and it's slower throughput through your shop. Another area with solvent, and quite frankly what accelerated the adoption in the US and Europe, is very stringent regulations on VOCs. So that really kind of kicked people into gear, even when it was at a higher cost, and so that has to be acknowledged. I think beyond that, you look at other parts of printing. With UV printing, you can use a less expensive substrate because UV adheres on a much wider range of substrate. And solvents, you have to have a certain type of substrate. Yes, it's a wide variety, but UV you can often do on thinner substrates that wouldn't do well with solvent. So you really have to look at the total end-to-end cost. And then finally, the other thing that spurred it on, and you'll see this in retail as it grows, is people and customers start objecting to solvent output at the end user level. There was actually big retailers in the US and Europe that outlawed it because they found when they opened up the container and they rolled it out on the floor to put up in a display, it outgassed and it was objectionable. So again, you have to look at the cost end to end, and then finally with LED, that's I think the other breakthrough we've done specifically at EFI, because we've taken the energy costs of running a printer down dramatically. So there's a lot of different factors in the cost that you have to look at, and it's from the acquisition of the raw material all the way on through to what is costing your customer. And I think in that context, actually, LED printing for sure is, I think, very economical.
Thank you, both.
If there are any questions for Dr. Wagle, also, please ask.
Hi, my name is Pravesh, and I actually have a question for Dr. Wagle. He's right here actually. So my question is related to printed electronics actually, and in December 2014, I attended one seminar in Mumbai actually, related to Bombay Printers Association. Fahim runs that actually, and there was a company from Pune who came there and they were presenting their case basically, and what they have done a lot of in-house innovation basically, because there are no tools available to produce or to manufacture this type of things, right? So one part is that there are not enough tool to mass produce or to cater to that segment which is called printed electronics. That's one of the challenge. But what are the other challenges you see from your point of view, and where companies like EFI or Komori or these large companies in printing, they can help develop that segment so that it can flourish and we can get benefit out of that?
The major challenge we face is the sintering and drying challenges, because most of the chemicals are prone to high temperature and moistures. And we cannot use higher temperature because we use substrates like polyethylene terephthalate or polyethylene naphthalate as a base substrate. So if there is a sufficient curing process, there are organizations who claim flashlight curing is a better process for printed electronics in the place of conventional curing processes like heat or UV. So if you integrate such curing process in the inline printing machines, that would be of great use for a printed electronics perspective.
Thank you.
if the advisors also have questions, they can also jump ahead. Anyone
Hi.
next?
Can I? I'm okay here. Okay. I have read that inkjet printing is not much demand in India than laser printing in the past years. Do you see that it is? I also saw the numbers like in 2020 we are showing like 50 to 60 it will reach 54 some numbers. So do we see that it is a great growth for inkjet printing in India, especially India?
So the question related, why, basically growth of inkjet and inkjet printing in India in particular. Actually, if you look at it, it comes down to the segments. So if you look at office printing, production printing of page sheet sizes, or what I would call small wide format, where laser can be done and imaged on paper, that is true. But all the inkjet we're actually talking about here today can't be done on laser. It's just the sizes are too wide or the substrates are not compatible. So if you think back to the slide I talked about on contactless printing, that's the key, is the print head doesn't have to make contact with the substrate. And so you can get all kinds of widths and sizes and also all kinds of different material compatibility that you just can't get with laser. So you have to really, when you see those overall statistics, then break it down into what are the different applications at the end. And that's when it starts telling, I think, a different story.
No, I think you covered.
I have a question to Scott, actually. Hi, Scott. When actually the digital printing came into the picture, probably about 2 decades back, predominantly all the billboards were only hand-painted or offset-printed posters being pasted onto it. Well, I do remember in Bangalore when the first digital printer came into city. All of them are, the hand-painted billboards. Only one on the MG Road, one digital printed billboard. People used to flock and see how it is being done. It's a big surprise. Later, all these digital printer manufacturers, the kind of push they put in or the power they punched into the corporates, the brand guys, marketing guys, why do you need? From a ₹2 printing to a ₹100 printing. It has taken a big jump. When these companies could do that, allow it to jump these marketing heads to go, why is it we are still struggling to jump from a ₹10 to a ₹100 jump with UV? Obviously, is a better print, matured, better technology, print, pack immediately and send it across. You don't have to wait, irrespective of the color gamut, there's a dark black, a dark magenta, dark cyan, it doesn't matter, but you still can immediately within seconds pack and send it across. But why is it companies are not able? Because EFI alone has about 5 to 6 large format UV printers today in the country. And this has been, last 1 decade has been sold. Why is it you're still lagging behind to push this?
In India in particular? I think there's a couple unique barriers in India. When I look at it from as a manufacturer worldwide, first off is India has the highest duties in the world on ink and on printers, 30 to 40%. So when I come to sell you a printer, you automatically add, by the time you do duties, insurance, freight, 50%. The only other country that approaches that we sell into is Brazil, and equally the same type of challenge. So what's interesting is there's a lot of commonalities of when I look at it worldwide between Brazil and India in terms of adoption of UV. The second reason is I think it's the allure and attraction of very, very low per liter solvent ink pricing. And I think when it's looked at very narrowly, as that's my main cost, substrate plus ink plus machine, UV will never match that. And I think it has to be looked at more broadly, as I talked about before, because there are hidden costs right now. And often, quite frankly, what it took in the other markets was a bit of government requirements that basically forced print providers to very quickly adopt. And also what happened in the US specifically, it wasn't even so much the government, it was the end customers who started really, it was a green revolution, if you call it. And Germany certainly fits in this. The customers came back to the print providers and say, I don't want solvent anymore, and it just forced it. So some of that's missing in India. I think it's incumbent upon us, and I take it on as a challenge. We have to come out with the right type of appropriately priced products in terms of inks and equipment, and also, quite frankly, do a better job of helping our customers understand all the costs. So I think it's just going to be time. I think it's a huge opportunity. I think it's going to happen here. The other thing that's going to happen over time is as more and more retail comes, the middle class economy grows very rapidly here. Quite frankly, labor is going to become more expensive. It's going to become harder as a print provider to throw people at it. And so you will be looking at new ways to, quite frankly, lower your labor. And we've already seen this in Europe, and especially Germany, where labor is some of the highest in the world. And then, of course, the US, which kind of follows. So I think there's all these things. I think it's in place. That's why one of the main reasons we decided to acquire Matan was we wanted very quickly to establish strong position in a more economically priced product that would fit a market like India better. So I still think it's a big opportunity to go.
Yeah.
Good question.
Let me talk on inkjet printing on packaging. Say, for example, now very simple applications. Say every pack which you see, virtually every pack which you see in India, there is a batch coding, date of manufacture, etc. Now all this is variable data, and all this is through a inkjet printer. Now you please realize that on a packaging machine, there are 8 pouches, or for example 10 pouches being made together. So you have multiple heads of all inkjet printers which are printing. Now this is all variable data. Now as time goes ahead, you will see the amount of variable data which is printed for tracking and tracing is going to increase. So the more and more space will be needed in which you will have to print. And for example, what about designs also? Say for example, the barcode which you get on a laminate now is pre-printed. Now suppose you want to, suppose you don't want to have a pre-printed barcode on the machine, but then you have different SKUs on the line. Now how will you do it without an inkjet? And there are so many of them. There are so many of them because India uses so many small packs. So many small packs, so many large packs, and so many of them together. There is virtually no other printing method by which you can do all this. So this very simple form, but I see them increasing.
Yeah, I think what you really, with packaging in particular, quite frankly, the speeds of inkjet are too slow today to really even get the, kind of the lower volume part of packaging, because the lower volume part of packaging is still huge volume. Really what I think packaging needs and what's going to break it open is single pass or full width array. So that's basically where you can do digital inkjet printing at what I call line speed, what you have with offset today as an example. So that's one part of it. And I think the technology is coming up soon. So, we've talked about it a lot in the industry, but we realize that's going to be the breakthrough for packaging. But then the other thing's going to come up. So pretty soon we'll be able to, the industry will launch into single pass or full width array, but then the next challenge comes up. How do you feed the data in quickly enough to get all the power of digital and individually customized down to one? So like with barcodes as an example. And that's something where I think at EFI, that's what I get really excited about. We have a hidden weapon. It's called Fiery. fastest video processing speeds on the planet. And feeding all that data in to all the electronics. And by the way, when we, all of our inkjet technology over time not only incorporates Fiery, but we also have the Fiery electronics team deliver all the electronics, develop all the electronics for all of our printers as well. So the data pipes and the data rate going into the printer, that's going to be the next bottleneck, and I think it's one we're going to serve serve and solve concurrently. So I think at the end it's all about speed. The other area is the ink. So today, as great as UV ink is, it only hits a segment of packaging, and there's a couple reasons. One is cost, because UV is 100% solids. It leaves a layer when you feel it, a film layer, and that when you feel a layer, that means it's cost. It's just more material. Really, I think I think the other shortcoming of UV in a lot of packaging is some of the regulatory. So food safe, even if it's, whether it's direct food contact or indirect, there needs to be breakthroughs on the ink side as well to get the cost per square meter down, but also to get the, that ink layer down, because when you feel an offset print, it's very, very smooth to the surface. So I think it's on the ink technology as well as the data as well as the printer. So a lot of pieces, and obviously something we're, and other vendors are working very hard at to solve.
Another area which you see in India, which is rapidly growing, is printing on a metallized board. Now, if you see metallized board, which is a metallized polyester laminated to a board and then printed through UV. Now, this is a premium packaging in India, and more packs you will like to see this. And say the interdeck drying of UV ink is happening more and more, so that in offsets we are using UV printed cartons, a large number of them, and the entire thing is now well understood, and different colors, different intensities, different drying systems. Drying systems in the sense that different type of lamps and frequencies and things like this is being now quite well done in India. So this is also another area in which, which is growing very fast. Say for example, all the older offset machines are being retrofitted with an interdeck. Newer machines are coming with an interdeck. So this is also another area which I see that fast coming up in printing.
Yeah, and you bring up a very interesting point, and that is you get into the more specialized media, very thin film substrate. That's where LED has a huge advantage even over LED, because you don't have, it's 80 to 90% less heat being applied at the point of printing. And so it'll enable, I think, over time in like flexible packaging to use thinner and thinner substrates, which will obviously save on substrate cost.
So, any more questions from the audience? I'm sure we have people. DJ?
Hi. This is actually the discussion that Prasad and Scott were having about billboards and solvent versus UV. So my thoughts about this was, as Scott said, it's only legislation which will really make that big move to, you could say, outlaw solvents. But in a country like India, when you're talking statistics, like Prasad said, that 60% or something like that is the size of the UV market, then the point is that it's the high cost of ownership of a UV machine, whereas you've got just tens of thousands of small printers, and all of them, their first entry is only going to be solvent. So they all get into that. And Scott, the difference between the West and developing economies is that for us, labor costs still come second to capital costs. So we can have a variable labor cost and have people to seam a few more, to create a few more joints which won't show, as opposed to a wide format machine. The other thing that I noticed is, and that was a question to Prasad actually, because I haven't really been into the billboard market, I deliberately stayed away from it. But what I did see was that in the West, when they outlawed solvent printing and most of it went into UV, they moved into polyethylene as a substrate, PE. It reduced weight, it reduced shipping costs. So in terms of the overall cost to the customer, those were areas in which they made up for that additional cost of the ink and the process. But why is it in India we haven't really made inroads into PE? And if you're talking about environment friendly, then it doesn't sound right to say that, UV is a better ink, but I'm putting it onto PVC, which is non-recyclable, whereas PE is recyclable. So if you're looking at it as a total, in the total eco structure, if you're going to go UV, then you should go UV on PE. And then you'll probably have, but I'm kind of out of that market, so I wanted some words from Prasad on that. Yeah.
I'm poor at electronics, actually. A good question is that, the PE can be used for billboards. But the thing is that it requires a minimum thickness one. The one constraint that what we have is a thickness availability for seaming the layers. All the machines what we have are 10 footers, but the billboard structures in the country is about 10 feet. We have something an average about 30 feet by 40 feet structures. You want to seam the PE, it requires a minimum thickness. At least above 350 GSM is required. When you go for a 350 GSM PE, the cost of PVC of 240 GSM or 300 GSM is going to be, between these two is going to be damn expensive. Therefore, all marketing heads, procurement heads throw this out for the cost reasons only again.
So finally, it is cost.
It is cost.
That's the point, is that it's about cost. And so how is it that the West is able to do it? That's what my point is, it's a question of economies of scale. So in the beginning, everything is more expensive, but as it gets used, the cost will come down. I would imagine that the shipping cost of a roll of flex will be far higher than the shipping cost of a roll of PE. So personally, I think our industry in India hasn't really put its head together on the PE level. And if in terms of sizes of the billboards, the average size in the US is, I think, 60 feet by 20 feet. That's pretty much a standard size, which is big. So I know that I dabbled with it a little bit, but it wasn't our core business, so I didn't really pursue it. But it has always been niggling me that has the industry not put enough effort into PE?
Thank you, Prasad and DJ. There's a great conversation, but I think it doesn't end here. We need to probably continue this discussion. I have a question for Mr. Narendra. He's a veteran in this segment, mainly in the commercial printing. So how do you see inkjet proliferating into the commercial segment as well? Have you invested in inkjet at all, and what is your outlook towards that?
We are sticking to core offset. We are not in the inkjet. We might use it for proofing purposes or making a dummy, but otherwise no. The point is, if you are going into a smaller segment or going in 1 copy to 10 copies or 15, 20 copies, then maybe we can do it as far as the inkjet is concerned. But our front end doesn't allow that. So that's the reason why we stick to core offset. Thank you.
It's a totally different market segment, I guess. Okay. So next question I had was for Mr. Pai. I know you are pretty much interested in the high-speed inkjet, mainly from a packaging point of view. You have shown interest in Landa before. So what's your outlook? How do you see this market growing going forward?
Well, right now we're not using any kind of inkjet system for packaging. We're using digital digital systems for labels and for things like packaging, but not rigid, like flexible packaging. But they're not inkjet, they're kind of the liquid toner or whatever platforms. But I think we haven't found the right system on inkjet yet for those applications. But since a lot of packaging is moving to digital, I think always we're looking for solutions.
Okay, and okay, so are you planning to invest in that area going forward, or is going to be, we're going to watch how it moves and then look at it?
No, actually we have started investing in digital for packaging because I think, for various reasons, for the smaller runs and for other variability, I think there's a need for digital. So I think it's which technology provides the same quality parameters and the economics ultimately.
Okay, thank you. So on any questions from the audience?
Yeah, just one quick question here, Arun. This is Atul.
Okay.
This is a question for the panel. So we see a variety of applications emerging with this technology. Now, in terms of customer acceptance and transitioning to take the value of all this, new things which are emerging. So in India, what percentage do you see are the new entrants versus the existing entrants which are moving to this technology?
Whom is this question for, Atul? To whom is this question?
This is for the panel.
General?
I think anybody can answer.
Anyone? Asha, yeah, go ahead.
I can answer for the ceramic industry. I think most of the new players today are setting up their factories with inkjet printing. So traditional printing is really fading out, except in the case of double charge and soluble salts technology. Already today, most of the volatile manufacturers have transitioned into digital technology. Floor tile, it's a process that's ongoing. So in the case of ceramics, I can vouch for it that the new businesses will come in with digital technology for sure.
So one more question on textile printing. Mr. Udupa, so how do you see digital in terms of textile printing? I know you're not using digital as of now. You do the heat transfer papers and then you have some kind of a hybrid system. But what's your outlook on that front?
Yeah. See, the digital in textile is not new. It was there from last 5 years. But again, it comes when I try to research on this last couple of months, 6 months, even when I travel to Europe, going around the buyer, why you're not taking sublimation? Digital means direct digital is expensive, but the other part is sublimation print. When it comes to cost from the rotary printing and sublimation, so there is a difference. Like what happens the end buyer, look at me or you, when you see a garment on a print, clarity on a textile, it is immaterial for them. Maybe for the advertisement and all, it should attract. So, but after last 2014 onwards, there is a big change is happening. As on now, we are using less than 2% of the textile printing in digital. And as per the survey, because last year growth, they made a survey in the textile industry, and they said by 2019-20, at least 8 to 10% of the printing requirement they will be using for the digital sublimation. And I have seen this. Yesterday I have been to one of the big sublimation printer who sells sublimation machine for the other brand. And I asked him the statistics, how much you can sell. He used to sell 5 to 6 machine, and this year he's selling about 8 to 10, sometime 12 machine per month. So that is an indication people are moving towards this thing. But till last year it is only the groundwork. I think growth will come from this year onwards.
Thank you, Rupa. So, any questions from the audience?
I have a question here.
Okay.
Aaron. So, my question is to Dr. Shiva from MIT. Hello, Shiva. So, this is about the printed electronic product. Right. So, besides the quality of this product, the longevity of the product is also defines, the very quality of this product. Given that this is an electronic product, right? So electronics are known or prone to get damaged in a very short time. So having said that, so how do we ensure such electronically printed product is going to last for a little longer time A simple example, we have to keep changing our mobile phones once in 2 years. They don't last for a long time. So given the thermal conditions they may get exposed to, so how do we ensure such electronic product will last for a long time?
Yeah, to be frank, we are not competing with the conventional electronics with printed electronics product. So basically, there is a niche application for printed electronics products like brand protection in the security segment and in power generation, building integrated photovoltaics, where return on investment can be lesser than 5 years. So we are looking at such applications where the lifetime of the product and our application will be very minimal.
Oh, thank you so much.
So I think we are running out of time. I'm sure we'll have a lot of rest of the afternoon for discussions with the advisors. Just one last question to Sam. So Sam, you've taken up this new role in terms of the region, the India-specific sales for all EFI portfolio. So in terms of inkjet, what do you see that uniqueness in India market that has struck you?
It's a tough market. It's really hard. But every market in India is pretty hard. Essentially, I think, the real challenge is, since the solvent days where EFI had done really well, we haven't in a big way engaged with the customer. We haven't really, sold, quote unquote. So I think we are getting our act together. So I think this year was trying to get our act together in a lot of ways in post-sales support. And, what matters is that, you buy everybody. I would go in the field and I would talk to a lot of potential customers and ex-customers, and they would all agree that the quality that EFI printers produce is unparalleled. But the challenges have been in field support, post-sales support and consumables, etc. And so we are really, trying to get our act together on those fronts in terms of. So I expect, starting with PAMEX, where we are going to have a very significant presence in December, I expect next year to be a great year for us. And there's already a lot of interest. I think Matan is a great product for the market. There's a lot of interest that's coming out of there. So I think, having good quality service, keeping the cost low, that has been the predominant challenge that we want to try to get. Scott, you want to add anything?
I think also it's incumbent upon us. I think we need to show the whole value chain to a customer in terms of not just cost savings, but how it can be additive. And also kind of getting back to some of the earlier comments on why the adoption hasn't occurred yet. I think we need to kind of help customers see and understand other markets that have already gone through the transition, because I think it's going to give an advantage to somebody that kind of jumps ahead. They might line up with one of the big brands worldwide that demands this from all their print providers and get ahead of it. And then as that brand comes into India in a stronger way, they're kind of a leader and others follow. So just a thought. But I think overall, the opportunity here is exciting. It really is, just in terms of what's happening in the economy in India. I think also it's exciting because the capabilities and the talent set here is just, we've known that for over a decade, as I said. And I think it's just going to, as the world is all the growth in the economy worldwide, you look at it around the world, it's all about having a knowledge-based economy. And there's where India has a huge advantage. So I think it's going to happen pretty quick.
Thanks a lot, and thanks to everyone for a great discussion. I'll now hand over to Kelvin for the closing remarks.
Thanks, Arun. And, I must say this question answer session has been really, really engaging. There are a lot of questions that, a lot of us still have, and unfortunately we just don't have the time right now. But, next meet, we're definitely going to ask all those questions. I'm now going to hand the days over to Madhulika, who's got a few closing comments to say.
Thank you so much, Kelvin, and thanks a lot all the advisors for taking all the questions and taking the time to make the presentation. So now comes the time to thank everybody who have been a part of this meet. So before going to the thank you, like most of the advisors here know that we have something very ceremonious wherein we show what is our capability in EFI by presenting you with the gifts. So now that we are in the 5th meet, so I would like to take a quick quiz from the advisors saying, if you could tell us what all substrate did we print on before for all the 5 meets before. Anybody can take a stab on it. And you get a huge round of applause for that. DJ, why don't you?
Do I count for the...
No, Sam
I'm not
doesn't count
qualified.
for it.
Okay.
Sam doesn't count for it. Yeah, DJ takes a stab.
Yeah. I don't think I can get them all, but I know that the first one was ceramic.
Whoa.
And then we had something printed on canvas, which was done by... And then there was glass.
Glass, yes.
Yeah. So, but I'm missing one.
So the other one was showing a fiery capability, so wherein we took your photographs then and there and we
Oh yes.
made
And
it.
we did
Yes.
yes.
Thanks a lot. So this time we have a surprise. So except for Prasad, the rest everybody can guess what the substrate could be. T-shirts?
It will be fabric.
Sorry?
Fabric. Fabric? Textile?
Fabric, textile? No. Yeah?
But that's a good idea for the next one.
Okay, so that gives us an idea for the next one. So this time we have printed it on wood using our Viewtech printer GS3250, and we would specially like to thank Prasad for printing it on the printers and giving it to us. So thanks a lot, Prasad, for that. So I would like to call upon Scott to on the stage to hand over the gifts to our esteemed advisors. So may I call upon Asha? Asha, your presentation on ceramic tile printing last time was fabulous. Thank you. So thank you so much. Okay. And we have a photo option. Let's give a huge round of applause, guys. I know it's lunchtime. Thank you. I would like to call upon Mr. DJ Bangara. So DJ is our idea generator. He throws a lot of challenges at us. So thanks DJ for being here. I'd like to call upon Gautam Pai. So Gautam has been a veteran in the industry, receiving awards from Mumbai Mudrak Sangh. Thanks a lot, Gautam. I'd like to call upon Himanshu. So Himanshu is the young leader and a go-getter, and who is ready to experiment anything and everything. Thank you so much, Himanshu. Thank you, Scott. And I would now like to call upon Sam to give the gifts to the advisors. So I'd like to call upon Mr. Narendra. So there are a lot of laurels on Mr. Narendra for the quality of printing, and it would be right to mention at this platform that yesterday in the print week, so their group received 4 different awards. So give a huge round of applause to Narendra. Now I'd like to call upon Prabhuda. Prabhuda's knowledge and expertise is just synonymous with his name. So thanks a lot, Prabhuda, for always bringing this expertise to us. We would like to thank Prasad. Prasad, so this time, this whole gift, the beautiful butterfly and the colors, all these stand out because of your effort. Thanks a lot, Prasad. I'd like to call upon Sachindra. Sachindra, I mean, your presentation last time on the samples of t-shirts and everything were fabulous, and this time we have Reggiani. We can show you more samples, so thanks a lot for being here. And we would like to call upon our special guest today, Mr. Wagle, Dr. Wagle, for taking his time out and taking us through the printed electronics presentation, which is just wonderful. Thank you so much, sir. And last but not the least, I would like to call upon Scott. Thanks for coming here, and we could know the breadth and depth of what our inkjet solutions are, and we are really proud of it. Give a huge round of applause, guys. So while we have Scott on the stage, Scott, we would like to mention now that Sam has been the driving force behind this whole event. So we would definitely want to thank Sam for this event. So give a huge round of applause to Sam. Thank you so much, everybody. So all this event happens and you all come, gain a lot of knowledge, and it goes without saying that there's a lot of research and lot of work that goes behind. So I would like to first thank the facilities team for arranging this marvelously. I would like to thank the ISNT team for always being there, standing at the corner there like a DJ. So huge round of applause to them. I would like to thank the design team for all the collaterals and all the designs, and they are really creative. So huge round of applause to the design team. And last but not the least, the rest of the day you will be going to various breakout sessions, and there has been a lot of research put in there. So I would like to just mention the names. I would like to thank Hari, who has been supported by Manoranjan and Ilaya. Give a huge round of applause to them. We would like to thank Ranjit and Manju, supported by Suma. Pravesh and Raghu, supported by Kalyani. Sashi, Mukul, supported by Reshma. And of course, our own Ashok from the advisory council team. So thanks a lot, guys, and thanks to all the guests who have been here, and it has been wonderful time. So rest of the day is also quite jam-packed for quite a few people here. Their calendars are blocked, and the devil is me. So having said that, I hope you all will enjoy the rest of the learning session. So thank you so much.